Okay, let's talk about monotonic sequence. Monotonic a sequence is a sequence that either constantly increases or decreases. I know there is a lot of information going on right there because it is hard to speak, write, and then make it nice at the same time. Okay, let's do this line by line. I will start from the first line. That is a monotonic sequence. So once again, monotonic sequence either constantly increases or decreases. Okay, for you, you can pause this video, you can take a screenshot of this screen, and then you can write all that, and then you can resume to the video at any time. Okay, sequence that is either constantly increases or decreases. I have a sequence right there, A0, A1, all the way to AN plus 1, and then keep on going. And then I am saying that this sequence is bounded above if the sequence has a maximum value. So bounded above is a sequence that is increasing and okay, let's use this increasing. So how about we have 1 2 3 4 5 6. Eventually we will do 6.5, 6.6, 6.7, 6.8, 6.99, and then etc. But we will never go above 7. So we will never go above 7. So this sequence is constantly increasing and bounded above. So just like a graph, you can picture that as how about the graph of inverse tangent, the graph of arctangent. Do you remember the graph of arctangent? There are two horizontal asymptotes, right? The graph of arctangent. So as x approaches to infinity, y approaches to pi over 2. As x approaches to negative infinity, y approaches to negative pi over 2. If you don't remember the graph of inverse tangent, you can go look it up. So this one, when x approaches to infinity, the curve is approaching to pi over 2. So that is increasing and bounded above. And then decreasing and bounded below is when x approaches to negative infinity, and then the y is bounded below at y equals to negative pi over 2. So back to our sequence, is bounded below if the sequence has a minimum value. Okay, let's look at my graph. I know there is a lot to take. Okay, follow the color. So we have a blue, and then we have this one. What color is this? It's like a pink. Okay, let's pink or purple. Okay, blue, bounded above. So we have an upper bound. I draw an xy plane, and then I use a dash line for upper bound, and then I use another dash line for lower bound. And then what about monotonic sequence? So monotonic sequence increasing. Let's follow the red dot. So this is a monotonic sequence increasing, and then this sequence is bounded above. So it is approaching to this upper bound just like a horizontal asymptote as x approaches to positive infinity. So that is bounded above and increasing. Bounded below, monotonic decreasing, that will be the green dot, that is a decreasing bounded below. As x approaches to positive infinity, the curve approaches to this horizontal asymptote. Horizontal asymptote, I am referring to the lower bound. So the red is monotonic increasing bounded above, and then the green is monotonic decreasing bounded below. And then what about the orange? The orange is going up and down, up and down, up and down, just like the graph of sine and cosine. So this one I will say it is not monotonic, because monotonic is either increase only, or decrease only. The orange is increase, decrease, increase, decrease, increase, decrease. So it's going up and down, up and down. It is not monotonic, but this orange is bounded between M and N. And then what about monotonic increase not bounded? That will be this curve. So that will just go all the way up, not bounded. It will just keep going up, just like the graph of e to the x is going up. And then this one is going down, not bounded at all. All right, so that is monotonic. Okay, let's do some examples. So the first example, let's do, and let me move this to the right. Example. I have an equals to 4 minus 1 over n. Okay, what is the next term? So this is the nth term. The next term will be 4a to the n plus 1. That is equals to 4 divided by 1 over n plus 1. Okay, we can disregard the 4 and then just look at the 1 over n and a 1 over n plus 1. So 1 over n and 1 over n plus 1. Which one is bigger? So let's say 1 half and 1/3. Which is bigger? 1 half is bigger, right? So this is bigger. And then if you multiply both sides by negative, that means you have to reverse the inequality symbol. So negative 1 half is less than negative 1/3. All right. And then we add 4 to both sides. So negative 1 over n, we add 4 to both sides. There is no need to switch the sign because you add the same quantity on both sides. So that tells me the current term is less than the next term. So this is the current term. And then this is the next term. So since the next term is greater than the current term, and then this one we can say A1 is less than A2, less than A3, less than A4, and then less than, and then keep on going, less than AN, and then less than AN plus 1, and then keep on going. So this one we can say this is a monotonic. And the sequence is increasing. Is that bounded above or bounded below? Let's see. So this one, to say the bounded above or below, we have to let n approaches to infinity. That is 4 minus 1 over n. That is 4 minus 1 over infinity. That is 4 minus 0. That is equals to 4. So we can say the sequence is increasing and bounded above. So we can say A1 is less than A2 is less than A3. Keep on going, less than AN, less than AN plus 1, and then keep on going. But all of this will be less than 4. So we say that this sequence is monotonic, increasing, and then bounded above. Bounded. Bounded above, and then the upper bound is equals to 4. Okay, and then that is one problem. And then if you want to look at the graph, so let's say when n is equals to 1, you have 4 minus 1 over n, and that is 4 minus 1 equals to 3. So that is equals to 3. And then you can draw a graph like this. So this is a y-axis, and then this is a x-axis. So we start at 3. So we start at 3, and then we keep on going. There is an upper bound. This is a 4. So the 3, you can use a dot. So this one, you can just monotonic increasing, and then bounded at 4. So the upper bound is equals to 4. Okay, let's try a bounded below. So the next problem, I would like to do AN equals to 3 over 2 to the n. 3 over 2 to the n. What is the next term? The next term is an plus 1. That is equals to 3 over 2 to the n plus 1. That is equals to 3 over 2 to the n times 3 over 2 to the first power. All right. And then what is A0? When n is equals to 0, I have A0. That is a 3 over 2 to the 0 power, which is 1. And then A0 plus 1, which is A1, that is 3 over 2 to the 0 times 3 over 2 to the 3 over 2 to the first, that is equals to 3 over 2. And then I can see that the next term is greater than the previous term. The next term is greater than the previous term. And then what I can do is I can do A1 less than A2 less than A3, and then less than, keep on going, AN, and then less than AN plus 1, and then less than. And then what about the upper bound? So this one we can do a limit as n approaches to infinity. I have a 3 over 2 to the n. Then this is a 3 over 2 to the infinity. 1.5 raised to a very large power, and then this is infinity. So this one, did I say this one is a decreasing? This one is not decreasing. So this one, as n goes up, as n goes up, as n increases, the next term is always greater than the first term. And since when you look all the way to the right, so these terms, they are infinity. So that means this is not bounded. And then our conclusion is the sequence is monotonic, increasing, but not bounded. Then there is no upper bound. And then to draw a graph, we can draw a graph like this. And then that starts at 1, right? When n is equals to 0, that starts at 1. And again, I can use dots like that, 1, and then just keep on going. 1, and then just keep on going. So this will just increase all the way up, not bounded. Not bounded, no upper bound. As n approaches to infinity, an approaches to infinity as well. Okay, that will be the end of this video. If you like the way I explain monotonic sequence, upper bound, lower bound, give this video a thumbs up, subscribe to my channel for more contents like that, and I will meet you all in the next video.